Hello students, welcome to OrganiChemVerse YouTube channel. In this video I am going to explain one of the most interesting topics in organic chemistry, that is to classify organic compounds into aromatic, anti-aromatic and non-aromatic compounds. This is also one of the confusing topics for the students because they assume that they have to remember what is the aromaticity for a given molecule. But that's not the case. You have to follow certain rules. Then for any given unknown molecule, you can predict whether it is aromatic, anti-aromatic or non-aromatic. Of course, there are some exceptions which you have to memorize. So that is what I am going to explain in this video. Now, in order to be aromatic, the molecule must be cyclic and it should be planar. When a molecule is planar, whenever it is having sp2 hybridized atoms in the cyclic chain. One more reason why the molecule is planar, because it is conjugated. What do you mean by conjugated or conjugation? It's a alternative single double bond where the pi electrons are in resonance or conjugation. Along with all these three rules, it should also obey Hückel's rule. Hückel's rule of aromaticity. What is it? Hückel's rule is 4n plus 2 pi electron rule. Let's take an example to understand this. Let's take the most popular aromatic molecule, that is benzene. When 4n plus 2 is equal to number of pi electrons present in the molecule, so for benzene there are 6 pi electrons. How? Each double bond, right, it refers to 2 electrons. There are 3 double bonds, hence there are 6 electrons. Let's solve for n. So for n is equal to 4, therefore n is equal to 1. So after solving this, if you are getting n as 0, 1, 2, 3, so on, that means a non-negative integer, then the molecule is considered to be aromatic. We will solve many more examples, but first let's see what are anti-aromatic and non-aromatic compounds. In order to be anti-aromatic, the molecule must be cyclic, it must be planar. So planar or flat, okay, both are correct. So, and it should be having conjugation. It must be conjugated. Alternative double single bond must be there. And it should obey Hückel's rule of 4n pi electron rule. Not 4n plus 2. Remember, it's a multiple of 4. Okay. Let's take example and solve this. You can see that the molecule is cyclic and it is planar due to sp2 hybridized, and then there is a conjugation. Let's check for 4n pi electron rule. So 4n is equal to 2 plus 2. There are 4 electrons and n is equal to 1. Again, same here, n is equal to a non-negative integer 1, 2, 3, 4. Then it is anti-aromatic in nature. Now what are non-aromatic? Any molecule which will not obey any one of these rules. That means it can be cyclic, planar, conjugated, but it is not obeying Hückel's rule, okay? Or if it is cyclic, conjugated, Hückel's rule is obeyed but not planar, then it is non-aromatic. So that means if the molecule is neither aromatic nor anti-aromatic, then it is non-aromatic molecule. So the molecule can be acyclic or cyclic. It can be planar or it can be non-planar, right? So it can be conjugated, it may not be conjugated, right? So it can be, it may not be, right? But it will not obey Hückel's rule. Both the rules. Sometimes it may even obey, okay? May not be, we can write that, okay? So then we call it as non-aromatic. So then let's take example of, say, cyclopentane. Look at this molecule is cyclic, yeah. Okay, but it's a non-planar because the carbons present here are sp3 hybridized. This is one of the key factors. If you see any sp3 hybridized carbon in a molecule, maybe it is a non-aromatic molecule, and you don't see any conjugation also. Say if I write two double bonds also, right? So there is a sp3 hybridized carbon because of which it is non-aromatic. So this is how you classify aromatic, anti-aromatic and non-aromatic molecules. Now, why we have to do all this? Why is this important? Students, remember the reaction of the molecules, right? The reactivity of the molecules depends upon what nature they have. Their physical properties, their chemical properties also depend on the aromaticity of the molecules. The reason is aromatic molecules are more stable than non-aromatic molecules than anti-aromatic molecules. Anti-aromatic molecules are less stable due to their high energy. That's why anti-aromatic molecules are least stable. Students, remember this, mark this. The stability for these three set of molecules is aromatic is more stable than non-aromatic. I can write like this, more stable than non-aromatic, and the least stable is anti-aromatic. Okay, now in exam, what sort of questions you can expect? Which of the following molecules is aromatic or non-aromatic or anti-aromatic? Alright, so how to explain this? So usually the aromatic molecules are benzenoids. What are benzenoids? Having structure like benzene. For example, naphthalene. Alright, like this. So it is cyclic, it is planar, it is having continuous conjugation, that is double single, double single, double single, right? And it is obeying Hückel's rule also, 4n plus 2. How? 4n plus 2 is equal to, check the electron, 2, 4, 6, 8, 10. So solve for the n value, n is equal to 2. Even molecules like phenol, what is phenol? Benzene with OH, or aniline, toluene. So anything with benzene in it, it is going to be aromatic in nature. Apart from this, you can even have charged molecules. That means what? A carbanion, carbocation, etc. So let's take example of a carbanion. Let's take this carbanion. Now, is it cyclic? Yes. Is it having continuous conjugation? Yeah, this is little tricky. Observe here. Double bond, double bond, but single and single. But there will be resonance of these pi electrons. That means what? We need to consider these two electrons in the resonance. Therefore, while checking for Hückel's rule, we have to consider them as pi electrons because these non-bonding electrons are getting involved in the conjugation. So 2, 4, 6, that means similar to benzene, therefore it is aromatic in nature. Same way for carbocations as well. Let's check this. The carbocation is not having any electron, it is deficit, okay? And look at this, this is sp2 hybridized carbon. So although you don't see any conjugation here due to single bonds, right? As I was telling earlier, there will be continuous conjugation of electrons like this. Because of that, there are 6 pi electron, hence this is also aromatic in nature. Alright. They can be heteroatoms also. What does that mean? Let's take example of pyridine molecule like this. Now, pyridine is a heterocyclic molecule where nitrogen is a heteroatom with lone pair. See, just now I considered this lone pair in the resonance. I have taken it as 6 electrons. Now look at this, 2, 4, 6, 8. So it's supposed to be anti-aromatic, but why am I explaining in aromatic? Because these lone pairs are in perpendicular to the plane of these electrons. So they are not involved in resonance. They are not in conjugation. Therefore, only these 6 electrons are involved. Hence, it is aromatic in nature. That means what? The pi electrons which are in the plane. That's why we say it must have planarity, right? So all of them are in the plane. That's why it is involved. Whereas here it is perpendicular to the pi electron cloud. That means it is not involved. So this is something you have to remember or you have to learn. Then you can identify for any given molecule, all right? So it's not per se exception. It's just that you need to understand that when the electrons are perpendicular, they will not be involved in resonance with the pi electron cloud. So that's why they are exceptional, right? Now, let's get back to anti-aromatic molecule. For anti-aromatic molecule, we can write molecules like cyclobutadiene because there are 4 electrons. You don't have to solve the Hückel's 4n rule all the time. If it is a multiple of 4, right, like 4, 8, 12, then it is anti-aromatic in nature. Okay, remember that way, right? So we can even have a carbanion, carbocation like this. So let's take example of a carbanion like how we had earlier, right? So now I'm taking for 7-membered ring a negative charge because it has to be anti, right? So 2, 4, 6, 8 multiple of 4, so anti-aromatic. And same way I can take positive for this. Sorry. So let me redraw this 5-membered ring. So now positive charge 2, 4 multiple of 4, so anti-aromatic in nature. We can even write heteroatoms like this with the oxygen, right? There are 2 lone pair, but one lone pair will be in the same plane as we have here, but the other one will be perpendicular. So because of that we have 2 plus 2, 4 pi electrons. Therefore it is anti-aromatic in nature. Same with nitrogen also here in this case, right? So the 2 electrons here will be in resonance because the hydrogen will be the one which will be perpendicular. So that's why again it is anti-aromatic. Same with a boron present like this, right? So boron will have a empty orbital similar to this. So that's why again it is anti-aromatic, right? So these are some of the examples for anti-aromatic molecule. Non-aromatic, any molecule which will not obey this. For example, let's say we have a cyclohexane or maybe cyclohexene or hexadiene, right? Because there are sp3 hybridized. The moment there is sp3 hybridized, it's a non-planar molecule, all right? We can even take some exception molecules like a tub-shaped molecule. What is this tub-shaped molecule? It's nothing but a Cyclooctatetraene molecule. When you look at the molecule, it is cyclic, it's planar, it is sp2 hybridized, and there is a continuous conjugation 2, 4, 6, 8. So it's supposed to be anti-aromatic, but since there are 8 electrons, there is bending of the molecule and it will become tub shape. Tub shape means non-planar. Non-planar means non-aromatic in nature, right? So this is how you are going to classify the given compounds to aromatic, anti-aromatic, non-aromatic. What is the main application? Their stability. Aromatic more stable than non-aromatic than the anti-aromatic. For any given molecule, I think now you can classify it among these 3 set of compounds. Thank you for watching, and if you come across any molecule and you are not able to identify what sort of molecule it is, you can always post that question under the comment section. I'm going to help you with that. Thank you.